The New Horizons mission presented a real challenge for one of the most difficult space missions in human history. The probe reached Pluto and captured a rock on the outskirts of our solar system that no one has ever seen before from such close range. Or maybe we're not the first to see it, because what New Horizons found has scientists wondering. Is Pluto just a cold, lifeless rock? Or could there be more to this dwarf planet? 8 years later, the probe team is still studying the data collected during the flyby, making new and exciting discoveries that are changing the way we see our solar system. Is there really an ocean of liquid water hiding beneath Pluto's surface? What causes ice hills on the planet's surface? Learn about the fascinating things about how dwarf planets exchange materials with their largest cosmic neighbor, and take a trip to Pluto to see things you've never seen before. The New Horizons probe was launched on January 19, 2006. The main goal of the mission was to study Pluto, once considered the most distant planet in our solar system. At the time, it was impossible to see Pluto up close, and scientists were very interested in what the dwarf planet's surface looked like. Pluto is so far from Earth that the spacecraft had to come up with clever tricks to speed up its journey. Otherwise, it would take a very long time to get there. Just 9 hours after launching from Earth, the New Horizons probe orbited the Moon and approached Jupiter, the largest planet in our solar system. The spacecraft captured images of the gas giant and its moons, including Io, pronounced Io. The probe captured images of the active Tvashtar volcano, capturing eruptions 320 kilometers, 200 miles, into space. In 2007, the spacecraft flew within 2.3 million kilometers, 1.4 million miles of Jupiter, and received a massive gravitational assist from the gas giant. This small maneuver shortened the time to Pluto from 14 years to just 9 years, but there were still 8 years left to go. To keep the probe's electronics in good working order, scientists put the spacecraft into deep sleep mode. At one point, when New Horizons was about 5 billion kilometers from Earth, the mission team encountered technical difficulties. Because it was so far from the Sun, the 1,000-pound probe didn't receive enough sunlight to generate enough power, causing communication problems. The situation got worse as the spacecraft moved away, and when New Horizons approached the dwarf planet, its signals took about 4 hours and 30 minutes to reach our planet. About 4 months before approaching Pluto, the spacecraft's cameras began revealing the dwarf planet's unique features. Since then, the level of detail in New Horizons images has increased each week. Another challenge during the mission was the discovery of 2 crescent moons, Charon and Styx, orbiting the dwarf planet. This meant that there may be much more space rocks and dust around Pluto than previously thought. Researchers had to find a way to avoid potential problems if there was more debris near Pluto. The mission team had 2 backup options: use the antenna as a shield against incoming particles, or approach the dwarf planet closer than originally planned to reduce debris. Then, 10 days before the spacecraft's closest approach, something unexpected happened. New Horizons went into safe mode, and astronomers lost contact with the spacecraft. Luckily, it was just a computer overload. There was a problem with the spacecraft's command sequence. The team quickly regained control of the spacecraft and decided to take safety precautions by retrieving a special data set in case something went wrong after the spacecraft turned away from Earth for its closest encounter with Pluto. The fault-tolerant data packet contained images that would be lost to humanity forever if something terrible happened and security measures were not taken. No one has ever seen this stunning image of Pluto with its famous heart-shaped dot. This image showing the dwarf planet from different angles, or Pluto's moon Charon in vibrant colors. On July 15, 2015, a message from the probe reached Mission Control, informing astronomers that 13 hours earlier, New Horizons had successfully passed Pluto's surface at an altitude of 7,800 kilometers, taking hundreds of images and gathering scientific data about the dwarf planet's atmosphere and moons. But extracting this data wasn't easy. If you think your ISP has slow download speeds, consider this. It took a whopping 15 months to download the estimated 6.25 gigabytes of data. Because New Horizons is so far away from Earth, the probe could only send 1 to 2 kilobits of data per second. But it was worth the wait. For the first time, humans have gotten a detailed close-up view of Pluto's mountainous terrain. Some peaks are as high as 3,500 meters, 11,000 feet, and one of them is made of ice rather than rock. Researchers believe the icebergs are no more than 100 million years old and are a potential sign of recent geological activity. Here's another close-up, this time of Charon's surface, showing evidence of a landslide that occurred sometime in the past. New Horizons also captured several spectacular layers of fog around Pluto's atmosphere, stretching 20,000 to 40,000 kilometers, 12,000 to 25,000 miles, above the planet's surface. The fog forms when ultraviolet sunlight breaks apart methane gas particles in Pluto's atmosphere. The methane then forms more complex gases, such as ethylene and acetylene, that have been detected in the dwarf planet's atmosphere before. These gases enter the colder parts of the atmosphere, forming ice particles that appear as a layer of fog. This extraterrestrial atmosphere tells researchers a lot about what's going on beneath Pluto's surface. There, sunlight converts the fog into tholins, dark hydrocarbons, which turn parts of Pluto's surface red. Next to the largest of these glaciers is a white, heart-shaped region of nitrogen ice, 1,000 kilometers long, called Sputnik Planitia. The ice is so large that it has no equal in the entire solar system. Astronomers believe this is a relatively new feature on Pluto's surface and is very mysterious because its origin is still unknown. Some researchers believe it is an impact crater, and many strange things happen there. One of these strange things is that ice on Pluto turns into gas. Ice has a unique property called sublimation. If you keep it in a freezer for a long time, it will eventually disappear. This happens when ice slowly changes from a solid to a gas, and at the right temperature, it skips over the liquid because it prevents the ice from melting. The surface of Sputnik Planitia is covered with nitrogen ice in a geometric pattern that has long puzzled scientists. One possible explanation is that Pluto's icy surface experiences the same effect, but the ice deposits there are uneven across the surface. When the dwarf planet's ice is compressed, it creates complex polygonal patterns that look like ice hills scattered across Sputnik Planitia. Sublimation of the ice also creates ice ridges or blades on Pluto. We have something similar on our planet. Scientists call them penitents, but unlike the meter-tall ice columns that form on Earth, they can grow much larger on Pluto. That is, during warm periods, methane freezes and evaporates, reaching heights of hundreds of feet, the size of skyscrapers. As this freezing and evaporation continues over millions of years, the ice bends into blade-like shapes. Another mystery about Sputnik Planitia is its location. Scientists believe that the region may have moved across Pluto's surface over long distances in the past. They call the process behind this movement polar wandering, and if scientists are right, Sputnik Planitia could be responsible for the entire rotation of the dwarf planet. Pluto's famous heart-shaped region is experiencing a positive gravitational anomaly. The gravity there is different from anything else in the region, and this has a major effect on the dwarf planet's rotation. Attaching a heavy object to one side of a rotating object like a frisbee would have the same effect. According to scientific models, this is why there is a large ice sheet directly opposite Charon. One theory is that the mass hidden beneath Sputnik Planitia is an ocean. This is not a far-fetched idea. Data from the New Horizons spacecraft show that both Pluto and Charon are complex bodies with signs of recent geological and tectonic activity, suggesting that a subsurface ocean once existed on Charon and may still exist on the dwarf planet today. So is it theoretically possible that life could evolve in such a distant and cold rock? Seismometers on Earth and the Moon track waves generated by events such as earthquakes. The speed at which these waves move through various materials tells us about the composition and structure of the body's interior or inner layers. Similarly, ultrasound health screenings use sound waves to create images of the inside of the human body. The waves bounce back differently depending on the density of the tissue they hit, allowing medical professionals to see internal organs. However, on distant worlds without seismometers, astronomers infer the composition of the layers based on the density of the object. They can then build models based on the most likely materials, such as rock or ice. In one of these models, scientists suggested that Pluto has a layer of hot, sticky asphalt beneath its surface. Originally, it was an organic material like carbon that could be transformed into a thick, tar-like liquid layer beneath the planet's ice shell under extreme pressures and temperatures.